Good morning. How are you guys doing today? Star Trek, right? Well, welcome to my session. It's on infrastructure as code. And I usually like to do a kind of a conversation as we go through talking about this stuff. My name is Mike Benkovich. I used to be a developer evangelist for Microsoft, but now I do a whole bunch of different things. Mostly, I work for cloud consulting, doing a lot of Azure consulting. I'm an Microsoft Azure MVP. I've been involved with these conferences for a little while. And today, I kind of want to talk about diving into infrastructure as code. So if you're here for infrastructure as code, does that sound like the right thing? Why do we care? Infrastructure as code. Why do we care about infrastructure as code? Because it's time to build things, right? So how many people are developers? You know, okay. It's hard to see with the lights here, but how many are architects? Like to think yourself cloud architect? Cloud engineer. What's the difference? Architects decide what we should build. The engineer actually makes it work. Maybe a little bit of both, a little bit of different kinds of things. But what if you were out building and you're given, you know, a pile of bricks, you're given all the 2x4s, you've got your different things you need to go out, and you just say, okay, well, let's start building. I'm going to go out and I'm going to create a house. I'm going to build a castle. Imagine you have everything you need. And so you go and you're an expert builder, and you sit down and you start creating the most incredible house, the most incredible thing. And then you look at it and it's like, okay, did we have a plan? Do we need a plan? Do we need, you know, what's the point of blueprints, right? Or an architecture? It is so that we can have some way of knowing what it is we're going to try to build. Starting a road construction, which is kind of a thing we do up in Minnesota where I'm from. We have road construction, it's about half the year, and then we shovel the rest. But the thing about it is they were working on our road, and after they took up the pavement, they discovered that the infrastructure, the sewer needed to be replaced too. And so the 3-month project turned into a 2-year project, and they're continuing to work on that. You ever run into that? Yeah. Well, infrastructure as code, why do we care? I think it's probably comes back to being able to say that we need to be able to have a way of going out and creating something. If you start with no plan, yeah, you'll end up there. And the trouble with that is that, you need to have a way of going out and doing this. Now, I don't know how many people have worked with, have applications running in the cloud, and you've deployed them from the portal. You've got things set up and running, it all works. And the challenge with that is replicating it. I worked on a project not too long ago with a company brought in to, as a startup company. Went from 200 people to almost 2,000 people in about 12, 18 months. Tremendous growth. Medical device, they got approved. Okay, well, now we need to take this thing and we need to build out new features for it. So how do we do that? Well, you create a dev environment, right? Well, how do you create that dev environment? Well, they had it as infrastructure as a Word document. Here, just follow these steps. There's 37 pages of this document. Just make sure you click on the right things. And by the way, each of those fields kind of scratched off in paper and ink. So how do you recreate something? I mean, they did one better. They actually made it infrastructure as a video. So infrastructure is YouTube. So you just kind of follow along and create things. You know, the great thing about that is that you end up with, the leading edge, bleeding edge stuff. And it's like repeatability. There's a real need for this. But the challenge is what do we use? How do I know what to go out and take as my tool set, okay? I'm an ex-Microsoft guy, so I always use the Microsoft tools. It's like I rarely pull up JetBrains. I rarely go out and use the latest other tools. It's like Pulumi. It's like, I'm diving into Pulumi because it's a cool thing. And we're going to talk about it today. And there's some great cases where it fits in. Same thing with Terraform. Terraform was like one of those things where it's like, I don't want to do Terraform. But it was like, oh, okay. There's some real reasons for doing that. How many people use infrastructure as code today have a favorite? I can barely see any hands, but I think I see some. How many people use, if you use Terraform, say yeah. If you use ARM Bicep, say nay. If you use, well, not nay, but yeah, how about woohoo? Okay. How about Pulumi? Some? Ansible? How about Azure CLI? Azure commands, right? I mean, there's all these different ways we can go out and do this. And the thing about having code is code allows us to be able to avoid those things where you aren't trying to configure and do things. You're creating cattle, not pets. It's the idea is I'd want to be able to have, I'm not even sure if I'm advancing my slides. There we go. What you want to be able to do is create the same infrastructure every single time. And when I think about creating infrastructure, I'm also thinking about, okay, cloud governance. Is governance important? Do we like governance? Yeah, we love more governance, not the mints that come from governance, but governance in the sense of being able to name things, organize things, find things, tag things, being able to use consistent infrastructure. So like if I'm going an app service, I want to be able to say it sits in a resource group and it's in the same region. But there's these governance concerns that we need to be able to be thinking about no matter which tool we go out and use. And the idea is being able to go out and create an environment that I can use that same code over and over again to be able to create a consistent environment. You don't want to have those surprise bills where, for instance, I go out and I create a SQL Server database and it happens to be running the wrong plan and all of a sudden I spent $2,000 in a day because I used the default. I think they changed the default on that, but yeah, it was kind of one of those things where you go, I didn't mean to do that. So having something where you can say, no, I want to use the free plan or the basic SKU because I'm doing development, or I'm using a simple web app and I want to do it on a Linux server. Being able to do those things and being able to identify them. The importance of tagging so that you can do chargebacks, so that you can find things. But there's all these governance things that we really do need to talk about. And I've got a course on LinkedIn I did about all the governance concerns of that called Permit to Cloud. And I think there's another one, Creating Azure Landing Zones. And in there we talk about policy and these other things. But today we're going to talk about, assume that we've got those kinds of definitions already created. And we want to go out and talk about what is infrastructure as code. Code is, what developers, what we do. And the tools for using code used to be, I would get up and couldn't go through an entire talk without opening Visual Studio. Yeah, Visual Studio is how many people use Visual Studio? I'm just kind of curious as you're every day. It's a great tool. It's incredible. The team that builds it, they've been evolving that. I've helped launch every version of Visual Studio from 2005 to 21. Absolutely love it. And then this VS Code came out. And I don't know if anyone uses VS Code, but it's a code-focused thing. And it doesn't have all the wizards. It doesn't have the graphical interfaces. But there are ways of going out and doing things that are very powerful. And it's very nice to be able to go out and work with code. Another thing, working with source code management. I've still got copies of my Visual Source Safe disks in case anyone wants to install that. But Visual Source Safe kind of became Team Services, which then became TFS, which then became TSVS, Team Foundation Version Services. And it was great. I was doing the talk about how you can deploy to Azure using the TFS build, and it wasn't working. I was checking it up, and a guy at Microsoft, Donovan Brown, I was talking to him like, yeah, I saw you do this demo and it looked really great. And he said, well, are you using Git? And I'm like, what's Git? I'm Microsoft, man. And And he's like, no, you need to go with the time. So I switched it over to Git, and boom, it lit right up. And it feels like Git is kind of the direction that most of us are going. And it's great to have that because I can then go out and version and collaborate and work on these things. But having that code versionable, collaborating, reviewed, means that we can go out and build stuff that's going to work. And we've got all of those capabilities built in. Once we go to code, then I know what I'm doing, right? But the question is what kind of code do you use? There's a lot of options out there. ARM, Bicep. ARM is the Azure native kind of code. It's a great tool if you're going to go out and create a resource. When they switched from the classic Azure Fabric to the Azure Resource Manager, probably about 2015, almost 10, 12 years ago, the way it works is there's a bunch of REST APIs, and if I create another service, I just add those APIs. And what ARM does, Azure Resource Manager, is it manages how we go out and iterate on those. And the great thing about it is that I can go out to the portal and I can create an ARM resource and open it up. So for instance, if I go over here, I'm looking at my Azure subscription here. I went out and created, can you guys see that? Is that too small? That too big? I can go out and I can say, hey, I want to go out and take a look at like a storage account. And if I look at this, I can go and I can see, here's the resource visualizer. Actually, let's go back and let's take a look at the Stir Trek Terraform resource group. I created this just a little bit ago. The nice thing about this is that inside of here, I can see the resources that I've deployed. Notice I've got some sort of a naming standard because it's like Trek. It's got the app name, it's got the environment, and then what it is. I also should have some tags on here. So if I open up the essentials, you see, no tags. Oh, bad Mike. But I can take a look at the resources by going to the resource visualizer, and it'll actually show you kind of how the resources are all connected. And so I can see here's this, there's the database, there's the server, there's our application. If I look at my deployments, I can see here's the deployments that have run. This was deployed with Terraform, so I don't see any deployments. If we go over to one that is, like, say, this one, and I look at my deployments, you'll see here's the deployment. I can click on it. The nice thing about this is I can actually see the actual template that was used to create this. And I do not like how they've got the editor as this little window that doesn't fill the screen. It's like, it feels like it should be VS Code or the code, editor interface. But this has got the server farm you can see right here. It's all JSON, super easy to read, nice and verbose, lots of detail. People love writing JSON, right? It's our favorite thing to do because I like having all these different things. The challenge is that ARM as a language and as a template is a little bit on the verbose side. It's also kind of hard to author. VS Code has got some great authoring tools inside of it. I can go out and I can take a look at, for instance, an ARM template that would create this. And this is in my VS Code editor. And I've just collapsed down different sections of this. But I created this template so that I've got a couple parameters I pass in, where I've got the type, the app name, and the environment. And these are parameters that are passed into this template. It has some variables. I didn't add any functions, but the variables, if you look at this, define out how the names are actually constructed. And so it takes those parameters, concatenates them together, and creates a naming pattern that I can use throughout. If you're using ARM, you're using Bicep, you're using any tool, pay attention to how you name things. And what I've found just from a pro tip is trying to keep those in a single place where you can find them easily is something that's worked well for me. You could also put these into the actual resources and do these functions, but it can get a little bit ugly. So in here where I've got two resources, I'm going to create a plan, and there's the ARM plan. It's got the variable, the type, the service. It's got the API version it's running, and the other tools that it uses. Notice I can zoom way too far. And then I've got the site name, and I've got some outputs that I use later on. And the outputs will then give me my site name and my plan name that it gets from the calculations. That way, when I'm running through a workflow that does a deployment, I can take the output of this ARM template and use it as to do the deployment of code if I wanted to. So this is an example of an ARM template. If I wanted to deploy that, I would have a script that looks a lot like this. And in here, let me just make this a little bit bigger. So I go out and I've got my variables I set. Here's my app name. There's the environment name. We can go out and we can take these and say, okay, let's go ahead and apply them. Nice thing about code is I can do an F8 and it'll actually go out and do that. We can come down, we can say, okay, I'm doing an ARM template. An ARM template wants to deploy into a resource group. So the scope of that deployment is going to be at the resource group level. So I can go here and I can say, create this resource group, F8, and it goes out and it's going to create it. And then once it's created that resource group, I can come down, I can say, let's go do the deployment of that. So I can take these two lines here, and I'm using the command AZ deployment group create, which is going to actually do an Azure ARM deployment, and it's going to do the deploy of that ARM file or a Bicep file, either one. And I'll talk about Bicep in a second. But I can go ahead and run this, and it should then go out, verify that everything looks right. Let's take a look at our site parameters and see if we did that right. My site parameters, Trek 25, running for ARM. It's down here running. So when this gets done, then we'd be able to go out and see where that is going to live. And it actually shows up inside of here, where if I go out to my resource groups, and I'm going to search for all resource groups that have the name Trek in them. This is one of those nice things about the portal is you can find stuff pretty easy. So here's the ARM resource group we just created. There's the Trek plan. I can see here's my deployment as it's running. I've got the deployment. I can actually watch it as it goes. And it's created the plan. It'll create the site next. And then when it's done, it would take me to where I can see everything that's there. Nice thing about ARM is it's native to Azure. It's got all of the different features that make a lot of sense for me. So if I go through here, ARM is a declarative way of working with it. You've got a basic structure where you've got your parameters, variables, resources, outputs. When you go through and create a resource, you specify the different specific things for it, the metadata, like location, SKU, tags, other parameters about that type of resource. That resource is defined in that API, so you can go to that API and actually see what it should look like. So for instance, this is that app service plan. There are tools inside of Visual Studio, the resource group project type, where I can create a resource group and it's got some starter templates. I warn you that last time I looked, those templates are aging. They're from a few years ago. And I would not recommend using Visual Studio for working with ARM templates because it does not have the IntelliSense and it's lacking a lot of the things that the VS Code extension has. VS Code is a whole lot better, easier to get out there and work with it. Trouble is ARM is not the most readable, which is why they introduced Project Bicep. If we have ARM, Bicep animates the ARM, it basically, what Bicep is it was a recognition by Microsoft that ARM is not meant for human consumption. It can be complex, and especially when you got those variables and you're concatenating and strings and working with that. The tools are okay, they're getting better, especially ChatGPT and Azure Copilot, GitHub Copilot is a kind of an amazing tool. But what Bicep does is it allows us to have more of a language style, where I can have parameters and variables, and I can set up different things that look more like what a normal coding language would look like. It is still a domain specific, which means it's part of running inside of, meant for Azure. But the basic parts of it is you have a target scope, so I can target a subscription, resource group, management group, inside of Azure, and I can do a deployment that will create all of those different things. And based on the target scope, I can even create, I think I can create a B2C tenant I've used it for. You can use Bicep to get to a lot of different things. You have your parameters, your variables, your resources, and modules, which is actually kind of a cool thing because I can create a module that will connect and link up all the different kinds of things. And then I can also go out and specify my outputs. For example, this is an app service, going out and creating some parameters. You've got the way that I do my string interpolation. So I can basically use the different variables and reference them. So I take the prefix, I define it, and then I use that prefix in defining out my host name and my site name. One of the nice things about Bicep is if you want to get started with it, is you can decompile an existing ARM template. All I have to do is if I go into here, I can do AZ Bicep decompile, and I pass in a file name, and the file name would be, it's in /infra /arm/mysite.json. And what it'll do is it'll go through and it would create then a Bicep file. And I guess I just needed to use the -f on that. And that would go through and it actually update and create this file here, which is my site, which has everything. And the Bicep file then, assuming that it worked, shows that I've got the same basic things. I've got the different parameters. I've got resources. It looks a lot, to me, it's more readable than what the JSON syntax is, because you don't have as many quotes and placement, but it is almost important how you layer things. So you've got variables that come in. One of the nice things is I can take and I can work with multiples of these things by bringing them together, where I set a target scope, I can set my parameters, I set my variables, and I've got my resources. The nice thing about this is I can deploy this, and I will have that ARM history, that deployment history inside of the Azure portal of what I sent and when I sent things. And that's one of the nice things I like about the ARM Bicep story. Some people are like, yeah, but maybe I need to go cross-cloud. Maybe we've already got other things. Before I do that, though, any questions about Bicep? Yeah. Resource group. Yep. So the question was, in the target scope of the Bicep file, I say what I want to target at. And so there's resources, resource groups, subscriptions, and management groups are the 4 levels of taxonomy. And so I can specify, I can target a resource group, I could target management group. So if I want to do something that's like a policy, I want to apply it to everywhere. Good question. Any other questions? Are you guys ready to go out and use just ARM Bicep for everything from now on, forever? I heard a lot of people talk about Terraform, so obviously there's a reason why people do that. Why do people use Terraform? Does anyone use Terraform? Why do you use it? What?
People swear it's multi-cloud.
Multi-cloud, right? It's actually more than cloud. I can use Terraform to create info blocks records on my DNS. I can use it on New Relic to create ephemerals I want to go out and do a test. I can use Terraform to go out and create pretty much any kind of thing if I get a provider for it. So it's sort of like Ansible that can do a lot of different things, but it's not platform, not like Microsoft specific. It's a generic. What are the reasons? Why do people use Terraform?
It was first.
It was not first.
I mean, the one that got adoption.
It got a lot of adoption, but it came out, it was basically in response to CloudFormation on Amazon. Got some challenges, and not an Amazon guy, not going to say anything. But Terraform works really well with AWS. And it also works with other things. And they built the provider. HashiCorp did a great job of doing that. I know they recently are looking at how they monetize it. And I think that's one of the reasons people are like, okay, need to pay attention here. Am I using the open source or using the paid version? Those using Terraform, how many people are using the paid version? Okay. And it gives you state management. It's got encryption. It's got a lot of security. There's a lot of really great things. The Azure provider for Terraform, Azure RM, has been around for a long time. It is a little bit out of date, though. And I'm depending on the community to update and keep it up to date with what's there. So much so that Microsoft created something called the AZ API, which is a newer version of that, which is another Terraform provider for Azure that is a lightweight wrapper that goes on top of all the APIs. Nice thing about it is it's 100% up to date. But it's also, the thing about the Terraform I found was that it's very similar to, in format to how Bicep was designed. In fact, I would say Bicep is very similar to Terraform rather than the other way around. Terraform is a CLI, is just a command line, runs in the directory and will download and run the Terraform's stuff in that environment. You can install it with different tools. Your workspace is basically a folder that has some files in it. So I can go out and I can create some Terraform files. I set up a provider. I define my variables. One thing I like to use is locals. I don't know if that's something everyone else does or not, but that's where I keep, like local is like, okay, here's all the names I'm going to use throughout, and that way I've got them all in one place. You notice the syntax is very similar to what Terraform or what Bicep does. You create a plan, you can go out and you define it. You run some simple commands. Terraform init initializes the environment. Plan goes out and compares the template to the saved state. Apply applies it. Destroy tears it down. There's also Terraform show and some other commands that I can go out and I can save the plan to a file, and I can do Terraform show to take that binary file and make it visible so I can go out and pretty print, see what's going to change in the infrastructure. There's also Terraform state management that I can go out and I can import and work with the different parts of it. The cool thing about Terraform is that it's a very expressive kind of a language. I've got, for instance, here is a simple Terraform deployment. Does the same thing as the other ones. You'll notice I've got, actually this is one file, and this is actually the exact same deployment as this one. So let me take this over here. So if I look at the folders, for this Terraform folder right here, I've got two files. I've got a Terraform file and I've got a variable file. I could also, wow, really need to have a mouse when I'm doing the zoom it. This is almost the exact same thing, except I took that main file and I broke it out into different sections. And the reason I did that is because each section is sort of important. So the Terraform provider is the first thing. And that's where I set up what providers I'm going to use. I'm using HashiCorp's Azure RM for this. I've got a data, so I've got some references back to things that I want to use for my current configuration. In my main, I'm going to go out and I'm going to define my locals. I've got my resource group. I've got my naming pattern that I'm using. I've got the resources I'm creating. I've got the resource plan, the app itself, and then some settings. I have a section for outputs, so I define where those outputs are. I've got a SQL that I added to this. I just decided, well, I'm going to add a SQL server and do this deployment. And then in the vars, I define out all the variables that I'm going to use. And the thing about this is I can go out and say, okay, when I run this deployment, I can just go and change into that directory, infra/tf structured. And if I do a Terraform init, it's already been initialized, and I can tell because it's got the Terraform folders here. It's got a lock HCL, and I've done a plan and an apply, so I've got an actual Terraform state file. So if I go to Terraform apply, it'll go through and take a look at what's there, ask me for my variable names, stir track 25. How about olive? And then SQL admin password, this is important. Let's go. Can you remember that? Oh, that's the thing, because if you don't have the password, you can't get into this machine. So, yeah, make sure you secure your passwords. Security, does anyone care about security? I think no password. I think we should create this. You know, it used to be you'd install SQL Server with the SA password and it was blank just because you want to make it easy for people to use the database. No, not anymore. No, what we've got to do is we got to figure out how do we lock this down. I mean, the trouble with this, if I say yes, is it would go out and it would do this, and I've already done that, is, let's say, no, don't do that. I've got a TF state file. And the state file is basically going to, see, how can I make this thing so I can actually collapse that window?
Control J, Control V.
Yep. So this is the state file that gets created. And you'll notice that the Terraform state file, first of all, who should be looking at the Terraform state file? My DBAs, right? Because they're in charge of security. That's a joke. Sorry. I'm not serious. I didn't want to qualify. Terraform state is some important information because it tells us exactly what's there. And when Terraform runs, it compares the current state against what's going to be in the new shape, and whatever is different. It goes and applies those things. Like, for instance, if I go down here and I do you can see it's got the app service plans, it's got IP address lists, it's got all of this stuff. And if I do a search for GJ, there's there. So if you forget your admin password, so it stores it in plain text. Why? In case you forget it. Sorry, I should hide this. Okay. State is an important thing, but it's also something that can be secured. And because we know this, because you know this now, because you've seen this, you know how important it is to make sure you keep your state file under lock and key. Don't grant access to humans. When you run this, I run stuff through GitHub workflows. I've run it through Azure DevOps. When I do that, I create a service principal that has permission to a storage account that I put that state file into, and only that service principal can get there. Unless I, as God, decide that I want to get there too, in which case that's just because I'm a curious person. But I don't want my developers to. I don't want my DBAs to. I don't want anyone to be able to get to that information. You need to make sure that you know where you're putting your state and how you're managing that state. But if you're doing the right things, that's a good spot to be. Now, talking about the providers for Azure. Azure RM has been there for a long time. It's mostly up to date. It's not always up to date. There are some bugs that are out there, and there's a growing backlog of things, which is why Microsoft has invested heavily into the AZ API, which is a much lighter weight wrapper on top of the ARM endpoints. And in fact, AZ API actually operates ARM so that you can actually see all of those different things. In fact, they're probably going to move towards AZ API, so you kind of want to be paying attention to that. Any questions on Terraform before we move on to Pulumi? Yeah.
When you use AZ API, does it still write the data into the Terraform state and let you see it as a deployment in the Azure portal, or does it only show you what deployed in one place?
So that's a good question, and I don't know for sure, but based on what I know about how AZ API works, I would expect that the it would be writing it into the state file, because it does use that state to know if you change the password and it has to update things, it has to be able to have something to compare against. So AZ API doesn't get rid of that state thing. You still need to be paying attention to that. 10 minutes. We got 10 minutes. HCL language, less noisy, cross-cloud support. I really like that I can go out, and I recently used Terraform to do a Kong, which is an API management tool, and there's a Kong Connect provider. I could go out and I could use that, and this would actually go out and provision stuff inside that Kong Connect environment for the tools that we were using. I mean, that to me is a very powerful thing to do. For that reason, I think Terraform has got some real great capabilities. Talking about other options, though, Pulumi is one that is pretty popular. It is a multi-language. It was started by some ex-Microsoft people, in addition to others. But it's gotten a lot of support around people who want to be able to go out and create infrastructure as code, but from within the language they already know. So like Python, JavaScript, Go. What they do is they have a set of libraries. I can go out and I can create that infrastructure. I support the different languages. I compile down to the native runtime. I don't have to learn yet another language. For instance, that app service plan in C#, it looks like this, where I've got my plan name is equal to a variable, and I've got this, and I create the class type as an app service plan. I create the resource group, and I've got the constructors basically defining out what it is that I'm going to be using. And in fact, in here, I've got some Pulumi examples where here, I've got a C# stack that I created for all of our stuff, where I've got my app name, I create the variables, I create an app service plan, which is going to be a new type of app service plan, where it's got two parameters, the plan name and the args. The args have the resource group name, kind, there's a bunch of different things. If you're a Go programmer, you can do it in Go. So Go has got a different kind of a syntax. You basically are including the package for Go. So the package main, you import the Pulumi pieces. I can go out and I can define out what the variables are going to look like. If you're a Python, you can do it in Python. Main py. Import the Pulumi, set the variables, run this. If you're doing Node, it's TypeScript. So TypeScript is you've got the imports, same type of thing. But Pulumi as that language, when I go out and do a Pulumi up, it will log me into the Pulumi server, which takes this code and then applies it to my cloud. And so I am running through the Pulumi cloud to do this. It is a paid, there's a free version, but to be able to get to all the features, you end up paying per resource. And so there is a cost to using Pulumi. Any questions about Pulumi?
Do you have experience using Terraform CDK? And have you compared the two?
I have not dug into the CDK yet. That was on my list. I'm going to do that like tonight when I get home, because I meant to do that. The AZ API was the part that I added into this one, but the CDK, tell them what it is.
Yeah, it's Terraform, but it's kind of like Pulumi, where you're able to create your plans with programming language you're familiar with.
Right.
And there's also an AWS CDK where they also picked up on this idea.
Mm-hmm.
So I just wanted to
Yeah.
see if you had opinions or experiences.
And the scenarios that fits into is like, so if I'm an enterprise and I build my infrastructure that I run my enterprise on, and I want to check in those templates and I want that code and I want to use the Git repos to be able to be that source of things. That's one type of a business with cloud infrastructure. Another one is someone who sells cloud as part of a service. Like maybe I sell a blog and I want to be able to create a storage account for your stuff. Whenever you run your stuff, I'm going to create a storage account. And so creating that storage account, it doesn't make sense to go over here, check something in, and then I've got a repo that's got a list of all the storage accounts. It's like, no, this is driven by the business itself. And so I'm selling those types of things. And so whatever language I happen to be building in, and then using the CDKs, the Pulumis, those types of things, that's exactly the use case for it. Thank you. Other thoughts about this? There's a lot that we could talk about. I put together kind of a chart that kind of goes through from a high level, the languages, when you're looking at ARM Bicep, Azure only is a limitation. It's a specific solution for both ARM and Bicep. Terraform with AZ API, I think, is got a lot of great capabilities. Pulumi also, but it's also dependent on coming to speed. You've got the state files, but it comes back to who's doing this, and what does the teams look like, and do I always do infrastructure as code? Does everyone always do infrastructure as code? Yes, right, because everyone should be there. In the portal, you should have read-only permissions. You should never be able to change anything in the portal. Do you agree with that? Okay, because you're doing infrastructure as code. How about everyone else? Well, production, okay? I've got my business, it's running, and we didn't scale big enough to handle some load, and I know the load is going to come on. So I go out, and the first thing I do is I check out a branch of my infrastructure as code, go and find the scaling rules and add that to that, and then I run a workflow to go out and do the deployment. Or I go to the portal and I click on. You're the support engineer. Which one do you do? Okay, they go and they click something in the portal. What happened? What do we call that? Exactly. And there are times where you have break glass, and I need to go out and do that. Kubernetes. You've got, I'm scaling, and all of a sudden I've discovered that my pods, I need more IP space or whatever it is, or I need to apply some fix or some feature. Every time I change something in the portal, I'm drifting away from what that infrastructure as code that was deployed looks like. When I'm doing development work, sandbox work, stuff that's never, isn't in production or even in, QA or in the staging, does it make sense to enforce infrastructure as code there? Probably, but I think that's kind of a judgment call where you say, what does it take to be able to get into that? If you build with the infrastructure as code, you're going to build things that you can repeat. You can go out and build this again. You got repeatability. You got resilience. ARM, like I said, I've got a bunch of slides that kind of talk about that. AI. Because I know everyone's going to do that, right? So what does ChatGPT say? The scary thing is, how many people have used the GitHub Copilot with agents? Anyone? Have you heard of it? So, warning. Well, not warning. Heads up. Something's coming, and it's Copilot plus agents. It's this whole concept of they go out and do things for you. You can go out to GPT and say, yeah, give me an infrastructure code for each of these different things. When I put this talk together 3 years ago, it took me a while to get all of this stuff, months to get everything working. Today, I can go to ChatGPT and say, spin out up this, give me this, and it's just seconds, and you can get that code, which is where making the right decision or figuring out what makes sense for us to do our infrastructure as code is getting more and more important to understand the trade-offs and why we're doing these different things. And that's sort of, the whole point of this talk is not, okay, how hard is it to do these, but it's picking one and working with it. If you do make changes in the portal and you're, kind of evolving stuff, Bicep and ARM are using that actual Azure state for what's out there. If you're using Terraform, you need to do some state management. You need to import things that have changed. Or you need to, when you apply it, you have to recognize that those changes you made will go away. But anyway, to come back to this, there's a lot of different things you can do. Parameters, variables, very important. So I can create and use the same code in every environment. In ARM Bicep, I just created a TFR or a parameter file, and I pass in which environment I want to run. With Terraform, it's a little bit trickier because I use that folder as a workspace. So I need to reference from the workspace for that environment. And I create a folder per environment where I import in the different modules in the Terraform code that I use. So that's how I can run different environments, use the same code in different places. Pulumi, same thing. You've got variables. You can specify how you want things to run. So which is better? I'm a consultant. It depends. Tell me what you've got. Tell me what you're doing, what your scenario is, and it depends. Does everyone in this company need to use the same tools? Some say yes. Be nice. Reality is a lot of times no. And you use the tools that are part of that team. For stuff that I work on, we've got most of the infrastructure, the platform group, we use Terraform. There are some things I use Bicep for that are platform specific, like doing B2C tenant and some of the new Entra ID stuff that isn't available in some of the other providers. There's times where I might use the Azure CLI just to create a quick app service or a cluster that I'm just going to run something and then throw it away. So there are times to use different tools, but knowing what it is the scenario you're trying to do. Any questions? Did you enjoy that? If you want deeper information on all of these tools, I did a course on LinkedIn Learning that is exactly the repo that this is from. I've extended it a bit since I recorded the course. But also, if you reach out to me, that'll connect us on LinkedIn. I'd love to hear what you're doing with infrastructure as code. So thank you very much.